Okay, so hi everyone. I'm Victoria, and today I'll be talking a little bit about my master's project and how intercropping, specifically the Three Sisters, affects insect diversity and abundance. And just to preface this is the first talk I'm giving about this, so if it's a little rough, that's why, but I hope it'll be fine. Let's see. Perfect. So before I begin, I believe it's important for me to mention that not only was my project Indigenous focused, but it was also done on Indigenous lands. So for the past 2 years, I've had the privilege of working in Treaty 1 territory in the homeland of the Métis Nation. I also had 3 Ontario sites that were located on Treaty 3 territory, as well as right here on the Huron Treaty territory. Robertson Huron Treaty territory. I would also like to acknowledge that this project is a collaboration of a whole bunch of people and different funding agencies. So without all of these people and more, I definitely would have been able to get this far. So thank you to everyone. So for those of you who are unfamiliar with what the Three Sisters are, we're actually going to grow it here together. So traditionally, the Three Sisters are corn, bean, and squash, and those are planted within a mound. And there's actually a fourth sister, which is the sunflower. And this can be planted either in with those Three Sisters or around those Three Sisters. So one of the things that I was really interested in when it comes to the Three Sisters was the relationship these plants have with one another. The complementary and cooperative aspects these plants have incorporates a lot of the things that we would be looking for to conserve and restore biodiversity. So the 2 insects that I looked at for my project, the first one was native bees. Now native bees, the majority of them are solitary, so they live in places like hollow logs, stems, and underground. Their diet consists of nectar and pollen, and sometimes plant oils. So of course they are also providing pollination services, which accounts for about 35% of our global food production. The second insect I was looking at was ground beetles. So despite their somewhat mean appearance, ground beetles are actually beneficial insects. So like their name suggests, they live on the ground, similar to where you would find these native bees. So they're under logs, under rocks, under debris. They're also commonly found in agricultural fields. Now, generally, ground beetles are actually predators, so they feed on invertebrate pests such as aphids, grubs, and caterpillars, just to name a few. They also unknowingly save farmers about $4.5 billion annually in pest control, and I think that statistic is worldwide, not just in Canada, because that would be a lot of money. Their presence in an agricultural field is not really based on their food needs, but mostly based on the environmental conditions of that habitat. So that makes them a great ecological indicator for a very healthy and diverse environment. So if we look at this map here, we will see that our landmass is actually dominated by agriculture. Every shade of green is a certain percentage of land that is taken up by farming. Collectively, this equates to about half of our livable land being agriculture. So the way agriculture is done today is on such a large and intense scale. This drives the simplification and fragmentation of ecosystems, which can affect insect biodiversities in a really big way. So now I want everyone here to imagine that you are either a pollinator or a predatory beetle. There are going to be certain things in this habitat that you're looking for to think it's going to be a good home. So you'll probably be looking for nesting area, nesting resources. Alternatively, you'll also be looking for floral resources and pest resources. So we can see in the soybean field that there will be some of those things available. For floral resources, it will be somewhat basic. For pest resources, it's all going to depend on how the farmer manages their field. So like I said, there is some space for these insects. However, it will be very spread apart. Now, I want you to imagine you are still the same insect, but now you are living in a Three Sisters field. And we can already see here that there are going to be a lot more options for nesting area, nest resources, and food. And it's this diversity, or this insect diversity within this habitat and also the resources provided by the Three Sisters that I was also very interested in studying. So the idea that having different types of species within an ecosystem to drive function has been the focus of one of our most famous ecologists, David Tillman. So he used small plots to look at and basically build on the idea that the more biodiversity you have, the more effective an ecosystem is at being resilient and having those effective ecological services. Now, I am not as famous as David Tillman. However, I did try to replicate this in my very small system using the three sisters as the base for my biodiversity, which would drive insect function. So over I did 2 field seasons. And at the beginning, the idea, again, was to be the next David Tillman, where I would look at the 3 sisters and then also look at the different crop combinations and look at those insect diversities. However, this is really hard to do when you have a small budget, not a lot of resources, and when Mother Nature is really not on your side. So we're just going to look at the 2023 field season. And this is where I looked at insect counts within a 3 sisters field compared to the surrounding natural area. We also looked at those differences in terms of ecosystem services, as well as looking how the 3 sisters affected crop yield. So in 2023, I had 5 sites, 2 of which were in Manitoba and 3 of which were in Ontario. So we had one in Emo, Sudbury right here, and then also in New Liskeard. So all the sites look the same. They're about 25 meters square, and they had 49 3-sister plantings. So this included 8 plants, 2 of each cultivar. So we had corn, beans, squash, and sunflower growing all together. So for sampling, looking at the bees, we caught them 3 ways. So the first 2 ways were passive sampling. So this was using bee bowls, which are basically little colorful bowls that catch smaller bees. And then we also had blue vein traps, which are slightly bigger containers that caught larger bees. And that's what they look like in the field. The chickens were paid actors. And then we also did active sampling, which is what we called netting, where we would go to each mound and catch these bees by hand. For ground beetles, we sampled them only using one method, and this is called pitfall traps. And that's exactly what it sounds like. It was a little pit or container in the ground that the beetles would fall into. That's what they look like there in the field. So now we can understand how we caught over 14,000 insects over the 2 years. We can now look at some data. So here we have 2 species accumulation curves, which measure how complete our samples are to be able to give us a representative insect community by site. So the graph on the right, BVTs, which is blue vein traps, that shows how many bees we caught using those blue vein traps. And from this graph, we can actually see that we didn't catch enough to give us a clear community composition of those bees. And we can tell that because the end of that line, or the top part of the graph, does not come to a nice plateau relative to our pitfall traps, where we actually did get a more clear idea of those beetle communities. So because we know a little bit more about the beetles, let's look at those a little bit further. So on the left, we have our mean beetle abundance. So this is looking at the counts of beetles, regardless of their genus or species. And then we have on the right, mean beetle species richness. So that is looking at those unique species that we found within those beetle abundances. On the x-axis, we have our sites that we sampled. On the y-axis, we have our mean counts, and the bars represent areas within those sampling sites, which includes the 3 sisters and the natural area. So I did a post hoc test on both of them. If we're looking at the mean beetle abundance, as expected, we did see an interaction, which showed that the mean, or the count of the beetles that we found within an area depends on the site, or vice versa. For the mean beetle species richness, we saw the same interaction. So the number of species we catch within an area depends on the site. However, this interaction was fairly weak. So the next steps, we know insect abundance, we know species diversity. The next step would be go a little farther into those species and look at their functional diversity. So for example, We have the beetle Bembidion quadrimaculatum. So this is a very small beetle, smaller than the head of a pin. However, they are voracious predators against pest insect eggs. Then we also have beetles in the genus Pterosticus. So these are much larger beetles and much more aggressive looking. However, they are omnivorous, so they do eat insect pests, but they also eat assorted weed seeds. Now, for bees, we have two categories. We have specialists and generalists. So most people are interested in the specialists because they specialize on certain flowers. For us, that was Melisodes agilis. So they are a sunflower specialist that we caught a lot in our field. And then we have Bombus pennsylvanicus. So what is really cool about this generalist? First of all, generalists, they basically can pollinate any flower. But this one, we actually caught in our Three Sisters site. And what's really cool about it is that it's the second ever occurrence of this bee species ever being found in Manitoba since 1948. So I thought that was really, really cool. So on top of that, the next step is to then look at what drivers are actually influencing those diversities. And then we need to understand how they're influencing those diversities. And then through looking at all of these connections and all these differences, we'll be able to not only redefine what we know about insects, but how to better implement the Three Sisters into different environments. Thank you.
Thank you, Victoria. So Victoria and Annalie are sitting at the front now so that you get to ask questions. It's your turn. Those were very informative presentations. I liked them both. Questions from the floor. So we've got some mics that will be floating around. Yeah. Questions?
Yeah, I got a question about capturing the beetles. This was all in agricultural fields. How would that work in, say, a natural forest in the boreal? Can you collect the same species and come up with some kind of biodiversity function of based on the species you collected in a natural forest?
Yeah, so collecting the beetles could be done the same way anyway. So you would still probably use pitfall traps. There's other ways to collect insects like malaise traps, which I've never done, and they're very, very big. So pitfall traps are a less invasive way and an easier way. So you basically would just like dig a little hole and put a little container and then go check it. We checked ours, I think it was over 7 days. So then you'd be able to build that representative insect community that way. The reason why we build insect representative graphs is so we don't oversample, because our first year we actually had 70 pitfall traps in an area, and that's where almost 11,000 of our beetles came from. So you would do it the same way, you would just do it over a more spread out area, so you could do it using just pitfall traps in a forest.
Very good, thanks.
Yeah, no problem.
Hello, thank you very much. Sorry. Thank you very much for the talk. I have a very naive question because I don't know much about this, but perhaps you actually mentioned, I may have overlooked it, but over the course of the experiment that you did, have you noticed, for example, last summer when we had like this massive smoke everywhere, do you see some seasonality, strong seasonality fluctuations over the years and depending on when you had these massive smokes that we had last year?
Yeah, for sure. So last year, the smoke definitely, I think, affected the bees for sure, because the year before that, Manitoba experienced massive flooding. So I think the first 2 months of the summer, we couldn't even get out to the site because it was flooded. And we were about over a highway, and it was so flooded that we actually weren't seeing any bees. So yeah, I think that was a big difference, and I think the smoke definitely impacted those bees. We only saw mostly bumblebees this year, surprisingly. We didn't see a lot of the smaller, like Halictidae and like sweat bees and things like that, which was odd. So I'm going to assume that was probably the smoke, and it was very hot in Manitoba this year. So that as well, those two things.
Can you hear me?
Yes.
So it's interesting to see this year if that really affected like the next generation. Some mortality that happened, like absence of food leading to a drastic decline in the next season.
Yeah, that would be really cool to look at. Somebody might look at it. It definitely won't be me. Although it would be really cool if someone continued my work after. I'd like to continue it here in Ontario, hopefully closer to home. But I hope someone keeps looking at it because I think it's really important.
I'm Jean-Pierre Kapongo from Collège Boreal, and I'd like to find out when you made the pitfall to attract the insect, which kind of product did you put within to attract those insects? Did you consider the biology of those specific insects we have been targeting?
Yeah, so we do. What is commonly done for pitfall traps is basically windshield washer fluid. So we use propylene glycol, so food-safe propylene glycol, and we water it down, and it smells sweet to the beetles. Specifically, ground beetles are attracted to those sweet smells. Also, the pheromones of their pest insects and things are fairly sweet because of the plants and the plant sap, so that's the best way to attract them, although it does attract other things. We caught like harvestman spiders. I think we caught a few ladybugs. Most of them were invasive, thankfully. So we do catch other things, but that's the best method that people have found to use is using that propylene glycol. But food safe is the key there.
Yeah, I had a question for Annalie. Just concerned, not concerned, but if you've had any with the, especially with the carbonated water and some of these mushroom products, has it caught on a bit? Sustainability has to do, of course, with, I think at some point, some commercial success.
Yeah, so we have had quite a lot of support, especially within the Temiskaming area. There's certain farm stores who have asked to carry our product. But yeah, like you mentioned, right now our big constraint is this is a limited product, so we can only harvest so much and we can only produce so much. So the carbonated water has been quite successful. Actually, we've been able to ship that really across Canada at this point. But we're actually looking to take over the production ourselves. We actually were creating it in partnership with a local microbrewery called Barbara Brew, and they are shutting down operations, so we now have to find our own way to bottle and can our product. So it's been successful enough, but also at the same time, like you mentioned, the limited availability is making it really hard to market it on a larger scale because we only have, say, 100 bags of mushroom soup per season that we can make. So we do try our best to keep it local in the Temiskaming region, specifically within Temiskaming First Nation and for Temiskaming First Nation members.
Last question.
Where'd it go? Okay. I wanted to ask you particularly about in your harvesting and that, do you ever do wintergreen or hazelnuts? Are they abundant in your areas? And has there been a change in the amount of wintergreen? We've kind of noticed in areas it's kind of dropped off, in other areas it's picked up. Have you noticed that?
We do harvest both of those things. We don't have commercial products available yet using them. The wintergreen, we haven't noticed because it's not something that we've been doing for a long time. It's just kind of been since I started. And same thing with the hazelnuts. But we have noticed there are changes in species composition. Some of our sites are changing. We're noticing a lot of species are moving northward. So species that we wouldn't have had in the past are now making its way up to the Temiskaming area. We just assume that's because of the temperature changes and how that's a factor.
Wonderful. Thank you for those questions. Annalie and Victoria, thank you so much for educating us on the studies and the work that's being done in the indigenous agriculture world. Thank you very much. We have a gift for you. And I forgot to mention at the beginning, pour les personnes qui sont francophones, si vous avez besoin de poser votre question en français, vous pouvez le faire. Et il y a des gens dans la salle qui pourront répéter ou interpréter votre question